Hello, this video is geared towards manually finding the standard deviation and understanding that a little bit better. You can see on this page I have here, there's some stuff from the notes that we have in class. Down here you'll see the formula that we use to calculate outliers for the IQR method. That's also in the a different video, so if you want to look at that, that's in another video. This video is going to focus on how to calculate the standard deviation and kind of what that is. We use this in the finding outliers video to find, as a different method to find outliers. But today we just want to look at where does this standard deviation come from. And it's important because, to understand this, because if you look at this formula, you'll see that this big Xi represents all the individual data points. The X bar represents the mean of that data set, and we're going to subtract those. We're going to square all those differences and add them up. This is the sum, so we're going to add them all up, divide by n minus 1, and then take the square root. But what my point on this is that the calculation of this, when you sum all these differences up, it uses every single data point as part of its calculation. So it's like an average of how far away each data point is from the mean. But since every single data point is used in the calculation, this number is very sensitive to changes in even one number in the set. So a lot of times when we're looking for outliers or we're doing other work, we're going to use, instead of using the mean, we're going to use the median, because the mean is affected by every single data point in the set as well, right? You're adding them all up and dividing by how many you have. So every single data point affects the mean. Every single data point affects the standard deviation. So both of those numbers are sensitive to outliers and are sensitive to big and small numbers or just strange numbers, right? The median and the IQR and this method of finding outliers is not sensitive to outliers and is not sensitive to unusual points. It doesn't use every single point to find out what it is. The median is just half the data, right? I don't really care what those data points are, but I just need to know where the middle of 50% of them is. That's what the median is, right? Not affected. So that's a big topic in AP statistics is, when should you be using standard deviation and the mean? Well, if your data set is symmetric, then you don't have any weird data points. You have a nice symmetric set of data. Then the mean and the standard deviation are great tools to use because they are real specific. They use every data point and they have a nice number that is well calculated and it's a very specific number. But if your data is skewed, then these numbers will be skewed as well, which means it isn't accurate anymore, and you want to switch to the median and the IQR method. The IQR, like you can see here, right? Q3 minus Q1. Okay, so that's a big topic. That's why I'm starting with that, so everybody hears that. That's a big thing to think about. Okay, but we're going to get into how do you calculate the standard deviation by hand. I'm going to go through it real quick, just following this formula. I'm going to take every data point, subtract the mean from every data point. Those differences, I'm going to square. I'm going to add them all up, divide by n minus 1, and then take the square root. Okay, so here we go. I'm going to use the same data set I've been using this whole set of videos for this chapter 3. Let's do the, doesn't really matter, I'll just pick one of these sets. Let's do the AP Stats set of data from last year. And what you're going to notice is this is the number I'm going to calculate, this 0.113. This is what I'm going to be calculating. Okay, so here we go. I'm going to go over to the side. Let's call this the differences. And I'm going to, up in the formula box, I'm just going to say, okay, let me take my list. What was my list? This was AP Stats 2020. And I know I got it right because the name turned bold, right? So this is saying take all the data points in that list, subtract, and then I got to go over to the mean. What was the mean? It was at, I forgot where that was. Can I move this over? There we go. Got to go over to the mean of the first one, this one. Boom. I'll click on that. Okay, so I'm taking my whole list and subtracting the mean. and that will give me all my differences. Let me open this up so you guys can see this a little better. Okay, so that's the whole list minus the mean for that list. So you need the mean anyway, right? So you get that. And then you can see that they start off with some negatives. Why? Well, because all those numbers are less than the mean. And then towards the end of the set, they're all bigger than, they're all positive. That's because they're all bigger than the mean, right? All these numbers were getting bigger and bigger than the mean. So where it changes from negative to positive is where your mean is. I mean, obviously you were subtracting the mean from all those values. So these are the differences. I just need to square them now. So I will take, I'll just call this square or something, squares, something like that, equals differences. And you can see I'm just using the list names. When it turns bold, I know I've got it right. And I will use my caret and square that list. So I'm squaring all the differences in that list. Let me open that up so you can see. All right, so these are the squares. You'll notice that they're all positive. That's the reason this formula has the square in it. Like, why would you square them, right? Well, this is the reason. If I added all these numbers up in this list, you would get 0. Try it. Equals sum of the differences list. Okay, so I'm doing the sum of the differences list. This is 1 times 10 to the negative 13. That's 0, right? That's a decimal that's so small that you can't even, it's got 13 decimal places before the 1 comes up, right? So this is 0. So if you add all your residuals, what we call them, sometimes we call them residuals, but this is you can also call them differences, that's fine. If you add all your residuals up, add all your differences up, you'll get 0. Why? Well, because half of them are below the mean and half of them are above the mean. That's the way it works. So if I want to average those, that's not going to work. I can't just add them together and divide by how many I have, because when I add them up, I'll get 0, because half of them are negative and half of them are positive. I mean, not half, but almost half, right? So I don't want to have a mean of 0. That doesn't make any sense, right? I want to know how spread out my data points are. So what we do to get over that is we take these numbers and we square them. When you square them, it automatically changes them into positive numbers, right? So we have all positive numbers. So that's great. Then I should be able to just add those up. So let me do the sum of that list. Sum of the squares list. Okay, so that adds them all up. I don't have 0 anymore. That's nice. So this is the total. So now I need to, let me maybe just do total sum. I'll just kind of write it on the side so I don't forget. It's just kind of a label. Okay, so that's my total sum. Now I need to divide by n minus 1. Again, I'm just making a label. So, okay, so this equals this number. And then I have to divide that by, don't forget your parentheses, n. Well, what's my n? Well, in my first data set, I had an n of 23. So I had 23 data points. So I got to do 23 minus 1. So I will do that. So that's dividing by n minus 1. I'll just go back to the formula to remind you. So I did the differences. I squared all the differences. I added them up. And now I'm dividing by n minus 1. That's what I just did. I just have one more step, is to take the square root. Why am I doing the square root? Well, because I already squared all the numbers. I squared those differences. So to kind of undo that, I have to do the square root. And if you do that, you'll pretty much have an average of the difference from the mean. So it's an average distance, an average difference from the mean is what you'll end up with. It's a little different because I'm not dividing by n. I'm dividing by n minus 1. And people ask, why? Why don't you just divide by n? Well, because this is statistics, we want to include a little bit of error. We don't want to be so definitive and miss out on something that really was an outlier maybe, or to misrepresent the spread a little bit and start making decisions about some medicine or changes in my company, or some big decisions can be made just by using standard deviation. So we want to introduce just a little bit more error in there so that we're not kind of overlooking something, right? We just want to introduce that because it is statistics. You have variability. We want to make sure we include that. So you don't need to know that too much yet. We'll talk more about like degrees of freedom and things like that later on. But this, just for now, think about it as a little bit of an error included in the formula. Okay, so let's, we've got our sum of differences. We divided by n minus 1. Now we just have to take the square root of that. You can use the calculator button over here to get your square root if you want, right, over here. I often will just type in here, just type in SQRT, and the calculator recognizes that as the square root. So the square root of that number, and hit enter, and there you go, 0.113. Oh, does that look familiar? 0.1136. Look at that, 0.1136. So this number that the calculator calculates for you is what we just did. That's how it does it. It takes all the differences, it squares them, it adds all those differences, the square differences up, divides by n minus 1, and takes the square root to give you an average difference, if you will. It's an average difference. And it should make sense. Let's look at all these differences. These differences were really close to the mean, so they're small, 0.01, 0.02, 0.03, 0.0, you know, that kind of thing. These differences, the ones at the very top, are really far away from the mean, so they're like 0.22, right? So we got like 0.01, 0.02 for the close ones. We got 0.22, 0.2, 0.14 kind of thing for the ones really far away. So what's an average difference or an average distance away from the mean? Well, that's about 0.11 or 0.12. That's kind of an average, okay? An average difference or an average distance away from the mean. So that's why it's 0.113. That should make sense to us, okay? All right, that's it. That's the standard deviation and the outlier, like the difference between outliers, the difference between mean and standard deviation, and then also the median and like IQR and stuff, and when you should use those because of skewed data or not skewed data. All right, look for other videos in this set if you have something around this topic that you're looking for.